Hello grade 10 American System, this is Mrs. Nancy, your chemistry teacher. Today I'm going to continue section 11.3 in chapter 11, reactions in aqueous solution. The objective of this section today is to predict the formation of a precipitate in a double replacement reaction. So please open your book to page 371. To predict the formation of a precipitate, you need to use the general rules for solubility of ionic compounds. So to find out if an exchange will occur, refer to table 11.3, which gives guidelines for determining whether ion combinations are soluble. For example, salts of alkali metals and ammonia are soluble, exceptions some lithium compounds. Nitrate salts and chlorate salts are soluble, also we have few exceptions. Sulfate salts, they are soluble, exceptions for compounds of lead, silver, mercury, barium, strontium and calcium. Chloride salts are soluble, exception compounds of Ag and some compounds of Hg and Pp. Carbonates, phosphates, chromates, sulfides and hydroxides most are insoluble, exception compounds of the alkali metals and of ammonia. Let us start with example 1. Will a precipitate form when aqueous solutions of sodium carbonate and barium nitrate are mixed? So, first, look at the equation below. 2Na plus CO3 2 minus plus Ba2 plus 2NO3 minus. First, when these four ions are mixed, the cations would change partners. So, the two compounds that might form are sodium nitrate, NaNO3, and barium carbonate. Now refer to table 11.3. As I said before, it will give you guidelines for determining whether ion combinations are soluble. So, first, remember that sodium is an alkali metal. So in the table, rows 1 and 2 tell you that sodium nitrate will not form a precipitate because alkali metals and nitrate salts are soluble. While row 5 indicates that carbonates in general rule are insoluble. So barium carbonate will precipitate. And Na plus and NO3 minus are spectator ions. So the net ionic equation for this reaction is as follows. Ba2 plus CO3 2 minus forming BaCO3. Now let's do sample problem 11.9, page 373. The question is, aqueous potassium carbonate, K2CO3, reacts with aqueous strontium nitrate, SrNO3 to identify the precipitate formed and write the net ionic equation for the reaction. So step 1, we need to write the reactants showing each as dissociated free ions. So we write 2K plus CO3 2 minus plus Sr2 plus 2NO3 minus. So step 2, look at possible new pairings of cation and anion that give an insoluble substance. Of the two possible pairings, we have potassium nitrate, which is soluble according to the table, and strontium carbonate, which is insoluble. So now we eliminate the spectator ions and write the net ion equation as follows. CO3 2 minus plus Sr2 plus forming SrCO3.